Hello everyone, Hussein here. In this video, I'll show you how to take a Flask and Postgres app and run it in a container. But before doing that, let's learn what Docker is. So imagine that you have an app that has certain dependencies and you want to run that app regardless of the host OS. So for example, let's say you built your software on Linux, but the client, for example, is running it on Windows. So in simple terms, you want to use a container, basically like a container to build your app with or ship your app in. So this is where Docker comes in. It builds your app in a container so that you can run it without any problems. So in this video, I'll be using Docker Desktop since you can use this tool to manage your images and your containers using a simple GUI method. Now that we've learned about Docker, let's write some code. Here I have a simple repository that I created for a video earlier, and I'll link this in the description. So we have this project that we want to Dockerize. All this project does is that it connects to an online database and then it enters a few records. To start with, let's now create a Dockerfile. And then, so this is where we create an image. So for creating an image, we first need to use a parent image or a base image. So in this case, I choose Python since our app runs on Python. And then I want to set a work directory. So in this case, I'll set it to root. Now that I have all of my files, I need to copy them over into this image. And then since we have now copied the project, I want to tell Docker to install all of the dependencies in this project. This can be done using a requirements.txt file. So let's create that. So I use pip3 and then I freeze is into a file called requirements.txt. And then I want to tell Docker to install everything from this file. So for that, I use the run command. And then since everything has been installed, I can just tell it to run like so. When the server starts at port 5000, I have to expose it. So now build our image. To do so, you write docker build -t. So that means I have to specify a tag. I call it backend Dockerized, and then which directory I want to run it from. So I'll run it from this directory. Now let's check if the image has been created in Docker. Great, as you can see, we now have an image within Docker. Now since we have an image, we have to run a container from this image. So to do this, we do docker run to run a container from this image -p. So the port of the host, then the port of the container, and then backend, the name of the image. So backend Dockerized. Okay, so let's see if it runs using our API client. Okay, as you can see, this doesn't work. So we have to fix this. To do so, we go to main.py, and then all the way to the end, we have to specify a host. In this case, it's going to be 0.0.0, which means to bind our interfaces. Okay, so now it means I have to rebuild my image. And then I run it again. Let's see if it works. I can make a GET request to this endpoint. Great, as you can see, it now works. In this section, you'll now learn how to use a local database instead of an online database. So to use Docker Compose, simply create a compose.yml file. And then here you start by creating what services you need. So in this case, I will be needing a service called web, which will be my backend server. And then I build it. So it means I build from this directory, and then I want another service called db, which will come from a Postgres image. And then I need to create my environment variables. So for example, Postgres password will be test. Then I need to create a username for this. And then I need to create my ports. So what ports I have to expose it to? I have to expose this database from the host port 5432, and the port of the image will be 5432. Okay, now that's done. So how do we run the Docker compose file? We simply do Docker compose up, and then it attempts to create an image and then runs the container from this image. Great. As you can see, it has now created an image and it is now running two services called DB1 and then Web1. So DB1 is our Postgres database and Web1 is our backend. So let's see if it has actually been created. If you can see, it has created an image, and then in your container section, as you can see, it's running two containers for Postgres and then our database and then our backend. Sorry. Now let's see if it works. Okay, so this didn't work, which means we have to fix it. As you can see, I exposed my ports in Dockerfile, but now I need to expose them in my compose as well, since we're using the compose file to build instead. So for this, I do ports, and then I do the same as I did with DB. Now let's run it again. Great. As you can see, it has now created a Postgres database and then our backend server for us again. If we go into our images and container section, as you can see, it has created two containers and then two images accordingly. Now let's see if it works. Great. As you can see, our code works again. Now our last step is to shift our online database to our local database. So if I bring my compose file to the side, we can do this. So the syntax is PostgreSQL and then a username. So in this case, it is test, and then my password, which is test again, and then the name of my database. In this case, it's DB. I'll name it DB, and then the port. So in this case, our port is 5432. So I'll connect it to port 5432. Now I'll have to compose up again. Okay, as you can see, it didn't work. This happened because in many cases, there might be a situation where the server has initialized first and then the database. So we want to tell Docker to first initialize the database first and then the backend server. So to do so, you write depends on, which is another clause, DB. So which means I need to first wait for the DB container, and then after that, I can use my backend server. So now I will start over and then I'll compose up again. Okay, so this works. But we can also put in another condition to make it better. Is called the condition clause. So to do so, we can just do DB and then we can specify the condition. So if the service has started, then we can start the backend. So I have to fix my indents. And then I can run Docker compose up once again. Great. And let's see if it works. Then I can add another post request to a certain author. And then if I get, great, as you can see, our code works. So there's another workaround to this. There might be another case, although where your DB service might have started, it might not be ready to accept connections. So this is where we can use something called health check. Basically, we tell Docker to ping Postgres and check if it's ready. If it is, then we can run Docker. So let's add a health check feature here. I want to check if the health is fine by running a command which checks if my database is ready to accept connections using the user, which I just called test. Now I have added the health check. I can now change this condition to see if my service is healthy. So if it is healthy, which means if this command runs successfully, my code will run properly and then it can start the service or my web API without any failures. So let's start over. So it's going to take some time, but it pretty much guarantees that my web API works without failing. Great. As you can see, our code now works fine. And then we can also get and post. That's it for today. If you guys like this video, please subscribe. And if you guys have any questions, please let me know. Until then, have a great day.